Hello and welcome to a new uniTFT designer video tutorial. My name is Jonas and I'm working for Electronic Assembly's development team.
Today's topic is an overview about the powerful tool EA uniTFT Simulator. First, we explore graphical features like copy content to clipboard. Afterwards, we go step by step through the simulation possibilities, including external hardware. The simulator is started if you press this icon in the uniTFT designer or use shortcut F6. The simulator represents the hardware and nearly reacts the same way. But for creating documentation or testing, we've included some add-ons. I want to start with a very simple but interesting feature. You can simply change the module type. This demo shows our 5-inch, the EA uniTFT 050 ATC. But if you think about using a bigger screen, you can simply change the module, for example the EA uniTFT 070 ATC, and have a look at the same project on a 7-inch screen. For creating documentation, the display content can be copied to the clipboard. You can decide whether you need the content only or if you want to copy the frame as well. Now I want to highlight the functions that simulate the hardware and start with the inputs and outputs. For this, I need a little more space on my desktop. I deactivate the frame and activate the I/O panel, and you can simulate all ports, even if you have connected additional port expanders. The module's inputs are simulated with these checkboxes. If I change the state, the display shows the changes at once. The outputs are simulated with these bulbs. They change the state if the module sets or resets an output. In the same way, you can activate the panel for the analog inputs. The 4 sliders represent the module's 12-bit analog inputs. As you can see, the raw ADC value changes if the slider is changed. Of course, the ADC value can be visualized in a voltmeter or whatever. Please see our other video tutorials for further information about the analog input. For the PWM output, there is an oscilloscope-like visualization. You see frequency and both pulse widths. If I change the parameters on module side, the view is instantly updated. Side simulation, the tool can be used to debug your project. A memory view is implemented, just activate the register view and content of the module registers and string registers are shown. Just input the registers you want to see. Even changes for the values are possible. The same feature is available for data arrays. The project logs the analog input every second and visualizes in the diagram. Starting recording, the array is filled. An easy-to-use online debugger is implemented as well. Just start debug and the execution is stopped on the next command. There is the content of the macro, the actual program execution pointer is highlighted. There are various possibilities to step through the code. If you hover a calculation with the mouse, the result is shown here. Of course, you can see the content of registers in the same way. I step through the code with single steps and add register 1 to the registers view. You can also enter called macros by pressing F5. Pressing F7 steps out. There is the possibility to work with breakpoints. Open the menu with the right mouse click and select the file you want to set a breakpoint in. Select the line and start the program's execution. If you want to simulate some commands that are sent through the slave serial interface, please start the LCD terminal. Here you can send commands and receive the answers from the module. For example, to get the module's version string, I use the command xiv. In my example markers, I print something in the display's terminal layer. I activate the layer with the command YDO1. Typing something prints on the terminal layer. Hitting the debug button again, we see the output from my macro that can be used for runtime debugging without breakpoints in the display. If your system has a serial interface, you can use the COM port as interface for the simulator. Just activate the hardware through File Set COM port and make the setting you need. The last point on our agenda is troubleshooting. If there is a problem on your simulated SD card, you can format it and reset it to default. Just find the function under Help About Clear SD card file. An overview about Memroy is listed here too. If you run into the problem with infinite loops in the project initialization macro or start screen, you normally can't start the debugger anymore. If that happens, please modify the ini file, which can be found in the root directory of the application under Simulator and Tools uniTFT.ini. Please scroll down to the key Debug and set the variable at start to 1. Before saving the ini file, please close the uniTFT simulator.
I hope you enjoyed today's uniTFT designer tutorial. Maybe you have time and play around a little bit with our other sample projects and enjoy our video tutorials.